हेलो ऑल, आज मिलते हैं वापस फॉर 12th स्टैंडर्ड applications of derivatives again. Someone wanted a video from maxima minima. Okay, an important problem, good question. So let's see क्या problem है and how it can be made simple. Applications of derivatives, maxima and minima. Let's see. All set? Okay. This is from the board paper, question number 17, exercise 2.4 from the textbook. A box with a square base is to have an open top. If the surface area of the box is 192 centimeters squared, find the dimensions of the box for maximum volume. Also find the maximum volume. Now in the textbook, problem is up till here. But when it was asked for board exam, they additionally had asked this. Also find the maximum volume. So let us see the process. क्या करना है maxima minima के लिए? Okay. First of all, open box, open at the top with a square base. उसका base square है और 4 vertical rectangles are there. I'll just show you. I have a box over here. Like this. Okay. This base is square. And you have 4 rectangles. 1, 2, 3 and 4. Okay. 4 rectangles are present. So, let us see now what is the total surface area. Okay. First I will show over there, then I will come back over here. Okay. So अगर base का अगर if you take the side of the square as x, base is a square. So let each side be x. So area of the square base, what is the formula? क्या है दोस्तों? Area of the square base का simple x squared. Right? Area of 4 rectangles. Now suppose the height of this is y. Height of the box is y. Now when I say height of the box, this becomes y. This is x, this is x. So what is the area of this vertical rectangle? X into y, length into breadth, right? So we have got 4 such vertical rectangles. 1, 2, 3 and 4. ऊपर कुछ नहीं है, it's open at the top to fill in water or something else, right? So there are 2 things. First is area of the base, which is x into x, that is x squared. Area of 4 vertical rectangles, xy plus xy plus xy plus xy, 4xy. ऊपर कुछ नहीं है. So total surface area of the open box will be x squared plus 4xy. Area of the base plus area of 4 rectangles. Okay, so this is what we get. This flap is not there. It is open at the top. So ऊपर का x squared लिया नहीं है. Followed clearly? Understood clearly? Okay, nice. Let's go ahead now. So x squared plus 4xy total surface area is given as 192. 192. It's given. Right? Okay. अभी उसके बाद क्या है? Remember, from the initial condition, usually we take x and y. आसान हो जाता है. R भी कुछ पकड़ो. Even if the radius is r, take it as x. Okay? So after we get the initial equation, separate out the value of y. Why do we have to separate it? That you will see later on. But from the given equation, separate out the value of y in this way. 4xy, keep it on one side, left side को 4xy रखो. 192 minus x squared. Okay, x squared goes on the other side as 192 minus x squared. So y is equal to 192 minus x squared upon 4x. That is how I separate out y. we need to find the value of y, which I am going to substitute in the next step. Now, why is it required? I am coming to that. Okay. For any maxima minima problem, get the value of y, call it as equation 1. Now, what is asked? Find the dimensions for maximum volume. Okay. So, maximum volume यानी you have to first write the formula for volume of the box. Okay. Now, volume of the box is what? Length into breadth into height. If you see here, volume of the box is length into breadth into height, x into y. So x into y will give you x squared y. That is v, volume of the function. Now whatever जो कुछ पूछा है मैक्सिमा मिनिमा के लिए, that has to be called as function of x. Whether area is to be maximum or volume is to be maximum, first write that respective formula for either volume or area. Now, after writing the formula, if you are going to call it as a function of x, then right hand side y should be replaced by this. That is the reason that value of y is very important from the first given condition, because only when you replace the value of y, after y goes सब जगह पे x आना चाहिए, then only you can call it as fx. Calling it as fx function as fx is very important, because for maxima and minima later on we get f dash x, f double dash x. तो fx बोलने के लिए naturally right hand side को सब x चाहिए ना, y की कोई जरूरत नहीं है यहाँ पे. So replace that by initial equation, I get this. Then I can safely call it as fx. That is, these are the two important things. Separate out y, substitute the value of y to get fx. I will just simplify fx now. So यहाँ पे x squared, y की वैल्यू इधर आ गई है, यहाँ से एक x चला गया, right? So when I open up the brackets, 192 into x minus x squared into x is x cube upon 4 रहने दो. So this is our final fx. Then usual method for maxima minima, we require f dash x, f double dash x. Clear? So let us find out f dash x first. अभी f dash x कैसे है? d by dx of fx is equal to d by dx of RHS. दोनों तरफ d by dx लिया है. Now d by dx of fx is f dash x. On the right hand side, d by dx of all this, कैसे डेरिवेटिव लेते हो? कांस्टेंट को बाजू को रखना है ना. सो व्हाट इज द कांस्टेंट हियर? 1/4 कांस्टेंट, कीप इट असाइड, इनटू d by dx of 192x minus x cube. Followed? Our usual method of finding the derivative. So let us find f dash x first. I will calculate now. Let us see. I can write here now. Let us see f dash x. वन बाय फोर कॉन्स्टेंट बाजू को रखा है. ओपन अप द ब्रैकेट्स. यहाँ ओरली कर रहा हूं मैं. डी बाई डी एक्स ऑफ 192 इंटू एक्स इज 192 बाजू को रखे. डेरिवेटिव ऑफ एक्स इज 1 minus d by dx of x cube is 3x squared. d by dx of x cube is 3x squared. So I get f dash x. (192) minus 3x squared upon 4. Followed? That is what I get. That is the value of f dash x. Followed? Okay. Now, as soon as I get f dash x, I should write f double dash x. Differentiate again. One by 4 constant बाजू को रखो. d by dx of 192 minus 3x squared. So I am taking the derivative of derivative. Second order derivative is required for maxima minima. So d by dx of f dash x, f double dash x. 1 by 4 into brackets open. d by dx of 192 is 0. 3 constant बाजू को derivative of x squared is 2x. You know this. So f double dash x 1 by 4 0 minus 6x is minus 6x. So f double dash x minus 6x upon 4, that is 2 3s are 6, 2 2s are 4. That is what I get, f double dash x. So without these things, we cannot go ahead for maxima minima. These two things are required. Okay? These two things are required to solve further. So let us see how to go ahead now. Okay? I'll rub this part now. Okay. Now the method is, put f dash x equal to 0. So 192 this step is necessary because you have to find the value of x. So whatever f dash x you get in any particular problem, you have to equate that to 0. Now solve that equation. 0 into 4 is 0, right? So simply rub कर देता हूँ. So you get 192 minus 3x squared equal to 0 because 4 यहाँ पे लेने के बाद वापस 0 आएगा. So take 3x squared on the other side, you get 3x squared equal to 192. upon 3 gives you 64. So x is equal to root of 64. यानी plus minus 8, but I can't take negative because x represents the base. Side cannot be negative. So x is equal to 8. So we got this as 8. Naturally this will be 8. सब जगह पे square base आ जाएगा 8. Now find out the height. Height is y. How will you find the height? Substitute this value in equation 1. करो substitute in equation 1. So y is equal to, वहाँ पे देखते रहो, 192 minus 8 squared upon 4 into 8. करो calculate. 192 minus 64 upon 32. करो calculate. 192 minus 64 कितना है? Upon 32. You get 128 upon 32. That is 4. Okay? So your first answer is, अभी एक important चीज़ है, हमको दिखाना है कि maxima जो है वो satisfy हो रहा है. The condition for maxima is being satisfied. So after getting x and y, let us check for maxima minima. ये एक आंसर हो गया अपना. Now how do we check for maxima minima? Okay, once you understand this problem, you can follow any problem. This problem is slightly lengthy, so this is our basic answer. Now to check for maxima minima. Okay, so let's check. I'll write with a different color now. Write with blue pen. To check for maxima minima, consider f double dash x. And you have to put the value of x. What is the value of x? X की value कितनी आई है? 8. Therefore f double dash 8. Right hand side also minus 3 into 8 upon 2. 2 4s are 8. That is minus 12. So after putting the value of x, if the answer is negative, that is f double dash 8, you can see here it is less than 0. So if f double dash x or f double dash 8 in this case is less than 0, then the given function is maximum or shows maxima. Ulta hai. If it is less than 0, it shows maximum. If it is greater than 0, then it shows minima or minimum. So because we are getting f double dash 8 less than 0, whatever is given to us is correct. That is, in the question we were given that show that for maximum volume of the box, and here we are getting the function as maximum. Okay, so because it is less than 0, you are going to say therefore, okay, and right here, final step. What is the function? Initially मैंने बोला था volume is the function. So because f double dash x or f double dash 8 less than 0, the function that is volume is maximum. That is what we wanted to show when dimensions पूछे वो तो आ गए, x equal to 8, y equal to 4. इतना ही टेक्स्ट बुक में पूछा है. But in the board they have asked find the maximum volume. So कुछ नहीं, just put the values over here and maximum volume x squared y. X is 8, y is 4. So 64 into 4 gives you 256 square cubic units. That is the answer. Right? That is how you solve for maxima minima. Find out f dash x. First write fx by replacing, don't forget, y, call it as fx. Find f dash x, f double dash x. Put f dash x equal to 0. Get two values or sometimes one value. Then get the value of y. And then show that the volume or whatever function area is maximum or minimum, right, according to the tests. Okay, and remember this that I told you, this is called as second derivative test. That means when f double dash x is less than 0, you get maximum. When greater than 0, you get minimum. I have repeated quite a few things many times today so that ये problem पक्का हो जाएगा. और मैक्सिमा मिनिमा का पक्का हो जाएगा. ओके, मे बी 20 मिनट्स लगे, नो प्रॉब्लम. Important sum. Please go through it, solve it, see it again. Right? Okay. Bye for today. Meet you in another day or two. See you.